It's recording now. Thank you. Thank you very much. M128, Tuesday, Thursday, and today is 2, right? 2, 2, 2, 1. Okay. I'm just going to write down some bullet points so that you know like what we're talking about. Once we get to the lecture a little bit more, go work on your homeworks, and maybe not today, maybe for Thursday, maybe not Thursday, maybe next week. We can take a few questions from you guys, not questions. We can work on homework problems when you stumble upon something. So it has to come from your end, and you have to present it or hold it in front of your camera or share screen, and then you guys will be working on it, and I'll be your basically translator. I'll just put it up on the board so that everything is recorded. So things like molecules, matters, molecules, elements. Within element is same as atoms. They're the tiniest particle. Particle is a sketchy word, so it can be particle or wave, but let's for the sake of simplicity and our understanding, let's say it's a particle. Okay? Atoms. Then we have electrons, protons. I'll just not talk about neutrons right now. Then we deal with the configuration, their electronic configuration. I'm just going to use the word configuration. Configuration. Then we have what else? Bonds between atoms. Bonds and their properties, different kinds, properties, whatnot. Kinds, properties, etc. Shape of a molecule, it's very important. Molecular shape, polarity, and how molecules happen by using a concept called hybridization. We have kind of touched upon it in the last class. Hybridization. What else? Anything important that pops up in your mind that you want to share? What did I miss? Like, we cannot write everything here, but anything else? Maybe a couple more bullet points. What else is there? I have something in my mind. Let's see if anybody can read my mind. It's a P word. Oh, I already wrote polarity. Never mind. Anything else that comes in your mind? I think that's pretty good. We'll just stay with that. Okay. We'll just stay with that. We'll put like a little line of control. Okay. So we're going to deal with certain elements, not everything in the periodic table, only a certain elements that will be like our course and our knowledge and our wisdom will be relevant to. They will be relevant to whatever our zone or our territory is. Okay. So what I'm going to do is I'm going to do this. I'm going to draw like a little mock periodic table on the left or on the right. On the right. This is going to be our little periodic table. Okay. And I'm going to start. That's not a straight line. That's an audio-visual demonstration. Okay. We're going to draw like some of the elements up here, okay? hydrogen, helium. I have some own set of colors for different elements. I don't ask me how what logic goes in there. Lithium, beryllium. I'm going to work backwards. Helium, neon, argon, krypton, xenon. Okay, and let's draw these lines here. Okay, going backwards, neon, then we have fluorine, then we have oxygen. Let's make oxygen green because it's in water. Okay, oxygen. Then we have nitrogen. Then we have what? Working backwards. Before nitrogen, who comes before nitrogen?
Carbon.
Carbon.
Awesome, thank you. And before nitrogen, before carbon?
Boron.
Boron. There you go. Okay. So what I'm going to do is I'm going to do this. I'm going to extend these lines. Fluorine, chlorine, bromine, iodine. Who is below oxygen? Don't cheat if you remember.
Sulfur.
Sorry?
Sulfur.
Sulfur. Is sulfur a very friendly element or not friendly element? How does sulfur smell? Do you know? Is it a pleasant smell? Or
Like rotten eggs.
Sorry?
Rotten eggs.
Rotten eggs. There you go. That's a specific gas that contains sulfur. Anybody knows what she's talking about?
Hydrogen sulfide.
What's the formula? Harpreet?
H2S.
Sorry?
H2S.
There you go. H2S is like H2O. Very similar, right? So I'm going to put sulfur in a color that I don't normally use. These are the three pens that I normally don't use because they're hard to read. Brown, pink, and what's that color? Orange. Let me put the sulfur in orange color. Okay, I'm obviously getting a little distracted, but this is good. Do you know an herb? How do you say it? Is it an herb in our cooking that Asian cooking uses a lot? Chinese, Vietnamese, Indian, and that herb has a certain smell. Some of us love it, some of us hate it, and if you use that too much, then it can really ruin your dish, your recipe. It can be a disaster. If you cook it with too much of that, it can be a disaster. Do you know what I'm talking about? That particular root or herb, not root, that herb has a sulfur compound that causes that smell. Do you know what I'm talking about? Starts with a G.
Ginger.
Ends with a C.
Garlic.
Garlic. Garlic has a thioester. We will discuss that later on in 128B. Okay. Remind me if you guys are still brave enough to take the second class from me. Okay. So sulfur. What's below nitrogen? It's a very common element that's found in humans and living systems.
Phosphorus.
What color shall I use for phosphorus? How about brown? What's below carbon? It's something that's found in lubricating materials in moving parts, like ball
Silicon?
bearings. Sorry,
Silicon?
let that be purple. No, let that be black. Let that be black. Let that be black. What's below boron? Anybody knows? It's it's a metal. It's a light metal. It's easy to bend. It's not as hard as iron. And
Aluminium?
aluminum should be what color? Maybe blue. Okay, I think this is good to get started. The vertical lines, I'm making them purple. So matter, keep breaking it down. Sorry, my bad. Let's specify pure matter. Okay. You have pure matter, whatever that is, aluminum, phosphorus, silicon, something like that, carbon. Then you have elements. Pure matter, if you keep breaking it down, you get to a molecule. Sorry, molecule. Molecule is the smallest particle of that matter that retains all the material properties. That's a bad English. There is no such word. I'm just kind of building my own words. All the properties of the matter, of the pure matter, is retained in that molecule, but it doesn't stay that way once you start breaking up the molecule, right? So if you take the molecule and if you break it down further, then you get atom. Okay, atom is nothing but an element. Okay, element, and a molecule is a congregation or a combination of bunch of atoms. Okay, same atoms, different atoms, at least two atoms. Sometimes it can be one atom. Okay, one atom, that atom itself is going to be the molecule. You don't need for the molecule to be together with another guy. And if you read inorganic chemistry, if there is any BS in chemistry student here, then if you're taking an inorganic chemistry course from Dr. I'm going to just call her Missy, Dr. Missy G. I think her last name may not be there for a very long time. She's Garrett right now. Okay, if you take a course from her, actually at this there's a little piece of information. She's the only authorized inorganic chemist in our department, but there are actually Dr. Masaki Uchida, who has been hired last. I don't remember exactly when. I think it's been like 2 years now. The pandemic has really got me confused about the sense of time. There are two other professors other than other than Missy, Melissa, and Dr. Uchida. There are two other people who are also trained in inorganic chemistry, who are not actually three other people. Three other people. You can think. You can try to figure out like who those people are. So they are also very good with the entire periodic table. Okay. So atom is the element, like, but when you break down an element, like you take a piece of aluminum, I don't really have a piece of aluminum right in front of my eyes right now. I don't have anything here. Or if you take a piece of iron bar, and if you keep breaking it down, eventually you're going to go down to an element, right? So iron element, one atom of that element means you cannot break it down anymore. Once you break down an atom, then you start seeing other things. Okay. When you break down an atom, when you break down an atom further, then you get three things, right? Let me use color coding. I have my favorite color coding. Why am I starting with 2? What is wrong with me? 1, 2, and 3. What are the subatomic particles in an atom or an element? What are those?
Proton and an electron.
Proton, electron, and
Neutron.
neutron. Okay. What's the shape of an atom? Is it like a linear, like a string? Is helical shape, or is it like a box, rectangular box, or a cubical box? What does it look like? Does it look like this? Yeah. Yes or no? Don't give me any gestures on your screen, even though your camera is on, because I'm not looking at the screen. I'm just looking at the camera. And don't write anything on the chat unless you're talking to each other. That's fine. Just I won't be able to notice it. Sphere, right? It's going to be looking like a sphere. Yes or no? Can someone say yes or no?
Yes.
Okay.
Yes.
Thank you. Appreciate that. Yes, appreciate that. So it's going to look like a sphere, and I'm going to just say it's going to look like this. Okay, it's going to look like a sphere, and in that sphere, which is a two-dimensional representation of a sphere, is a circle. Okay, where is the proton? In the middle, somewhere here, or on the surface? Where is it?
In the middle.
The middle.
In the middle. So I'm going to put like a little pit of the peach. You know, in the center you have the pit. That's that, and you have a proton there. Okay, so this is a proton, P, and electron is E, and a neutron is N. Okay, we're not going to deal with the neutron for the time being. I'm kind of zooming through it fast. Okay, where is the electron? Here, in with the proton, or on the surface?
On the surface.
That's where the electron is, right? And just for the sake of our understanding, it's going to be recorded in the video. Where is the neutron? With the proton or with the electron?
With the proton.
Okay. Very good. If we have to, overall, the whole atom is generally, well, not generally, an element, the way they're born, they're neutral. They don't have any charge. But is that how the entire, all the subatomic particles are? Is everything neutral? Or overall the molecule is, the atom is neutral, but that doesn't mean that all the particles are neutral? What's the deal there? Can someone articulate that? Is anyone charged here?
The electron has a negative charge and the proton has a positive charge.
Fantastic.
And the neutron is neutral.
Yeah, exactly. Okay. So that's that. We'll talk about what happens when you have the electron knocked out, or when you have extra electron. We'll discuss that in a second. Okay. So is it important, like when we go from hydrogen to helium to lithium, beryllium to the entire periodic table, then we have at a couple of places you have the transition metals hidden when you're filling in the D shell electrons. You know D shell. I'm not going to dramatize that like I do for Chem 8 classes. You guys already have seen that, so you know what D shells are, D orbitals are. So when we fill in the D orbitals and when we fill in the F orbitals, we cannot place them in the middle of the periodic table. How do we put 14 lines or 10 boxes here, right? So they're placed in separate areas. And those guys are called those 10 or those 14 elements are called transition metals. Like anybody knows a transition metal? Anybody wants to mention?
Zinc,
Sorry,
zinc,
zinc. And one
copper,
more. Sorry, copper, palladium, cesium.
gold.
Yeah, all those fancy metals are coming from there. That means they are using their D shell to be what they are. Okay, they are gold because they have some electrons in the D shells. Okay, I misspoke. What did I misspeak? I said D shell. Is that correct or is that wrong?
D orbital.
D orbitals. We'll get there soon. Okay, so the elements differ from each other. Hydrogen is hydrogen and helium is helium. Hydrogen is not helium. Neither hydrogen is neon. Neon is not fluorine. Fluorine is not aluminum. What's different? What's that property that's tied with here and here? What's that property called that deals with something to do with protons and something to do with electrons? What is that property? It's a two-word description.
The number of protons?
What is that called? What is that property called?
Atomic number.
Atomic number. Thank you. Okay. That's called atomic number. So let's say, so this business, the periodic table, I'm just going to write it down here. This is a very bad representation of a periodic table. Periodic table. I'm just putting stuff that we are going to be dealing with this semester. Periodic table, and periodic table is a list of elements.
Hey, come on out.
All the elements. Okay, that's totally fine. I like this is better than blank screen. We have elements
Hey, knock it off.
situated there. Okay. And the elements are they have their specific spot in the periodic table because some property is different from each other. What is the property? Somebody just mentioned it. Atomic number, right? Because atomic number is different. Location or spot is different because atomic number is, I'm going to cheat, I'm going to go in here. Because atomic number is different. Okay. Who has the smallest atomic number in the periodic table?
Hydrogen.
Or hydrogen.
What is it?
Hydrogen.
What's that number?
1,
1.
What's that number?
2, 3, 4,
Fantastic.
5,
Keep going. Keep going. 7,
7, 8, 9, 10, 11, 12.
etc. Things get a little iffy and sketchy, right? At that point, we will not get there. So atomic number is different, and because atomic number is different, every element is different from each other because their number of protons and electrons are different, right? So atomic number is the number of electrons or protons. They're usually the same. So usually number of protons is same as number of electrons. Is someone playing something in the background? Can you please turn it off? If you're going to do that, then you should probably turn off your audio, because I think that's disruption, unless it's related to the class. I don't know how it can be. Okay. Turn off whatever you're playing. If you're watching YouTube video, I think that's inappropriate. That's incorrect classroom behavior. Okay. If your dog barks, your cat meows, your kid comes in and mom says something, that's all acceptable. I'm all game for it. Okay. All right, so that's that. So this guy has its atomic number 1. This guy has its atomic number 7. I'm going to ask some random questions. How many protons does oxygen have? How many protons does oxygen have?
8.
8.
Very good. How many electrons does neon have?
10.
10.
Okay. I'm going to test your knowledge, going a little bit beyond. Okay. Boron. I'm taking a jump, but I think it's fair game for you guys because you guys have seen it. And I think this should be also like a kind of like a calibration for your existing knowledge with organic chemistry. Like you should be able to figure out how much you need to study to catch up. Or if you don't have to catch up, there is nothing like it, okay? Because I'm going to go through this chapter fast, unlike I have done in the past. I think I put everyone to sleep when I'm going extremely slowly. It doesn't help anyone because I just bore you guys. F minus. Okay, think about F minus. Okay, we haven't talked about what happens. How do you get a cation or an anion out of an element? What has to happen? If I ask you a question in the first quiz, how many protons, listen carefully, how many protons, this is called fluoride. Fluoride, like sodium fluoride, calcium fluoride, it's in our toothpaste. I don't know exactly what fluoride they put in there, but it's good for your bones and teeth. How many protons, how many protons does fluoride have? Don't think too much.
9.
Is that the right answer? Other people, anybody wants to challenge her Preet, or you want to agree with her?
Could it be 8?
Okay. One answer is 9, one answer is 8.
I think it would be 9 because
Because, hold on. Let me ask you another question, then I think it will become clear. How many, okay, one answer is number of protons, one answer is 9, and somebody said 8. Okay, we'll discuss that. So I'm not trying to make you feel uncomfortable here. What's the number of electrons for fluoride? Somebody else, not her.
9.
10.
Are you sure? How do you get a negative charge? Who has a negative charge? Proton or
With-
electron?
The electron.
It will be
Electron.
So hold on, I interrupted you guys. What's your new answer for the number of electrons?
10.
10.
10.
Yeah, oh. I think it's 50.
Can someone articulate like why so?
Because it has a negative charge attached to the
Okay,
atom.
it has a negative charge, and who has a negative charge? Which subatomic particle, proton or neutron or electron, right? So you cannot balance it. Whenever you are seeing an ion, then the number of charges are not balanced. That means something is screwed up. You got something extra, right? So when it's negatively charged, you must have an extra electron somehow snuck into that shell. Okay, you have an extra electron, right? When you have a cation or a positively charged ion, it's a different scenario, right? So the number of protons, anybody wants to tell, I mean, does anybody have any confusion that the right answer is 9 and not 8? Because proton is in the nucleus. When you are making a cation or an anion, all you're doing is you're messing with the outermost shell. We will talk about what it's also called. The outermost shell is the happening place. When you have two elements, a white element, it sounds like a white elephant, white element and a red element. They're both spheres, right? So when you have two white elements, they can make a molecule by sharing electrons or doing something, snatching electron from one from the other, whatever. I think these are going to be sharing electrons. So when they're making a molecule, when two elements are making a molecule, all they're doing is they're rubbing their shoulders. This is their outer surface. They're rubbing their outer surface, and then this is the happening place. The nucleus is well protected in the middle of the fruit. That's the pit. Nothing is happening there. Okay. The only time we organic chemists or biochemists, for you guys, for 128A or B classes, we're going to talk about the nucleus is when we talk about NMR spectroscopy. Not now, in this next semester. Okay. But if you guys take it from me. We are also going to be offering all these courses in the summer. So you might be able to get ahead by wrapping up 128B and maybe 129A or 129B, one of the labs in the summer. You can really speed things up if you are ready for the challenge. So whenever business is happening, it's happening on the outermost surface. Like you can make a homodimer, like two elements coming from the two atoms coming from the same element, or you can have two different elements coming together by sharing electrons here or by snatching electron from this guy to that guy, and then something like that can happen. You can produce a cation and an anion, then you have an anionic bond. We will discuss that. We're just setting up the stage as we speak. Okay, so all the happening is happening. What kind of English is that? All the things are happening on the outermost shell. Okay, you're not messing with the nucleus at all. When we are dealing with whenever you are learning stuff in this course or in the next course. Okay, so don't change anything in the nucleus. It's untouched. Okay, so if you look at fluorine, how many electrons and how many protons a neutral fluorine is born with? 9 each. Let's take a 10-second break. Every element on the periodic table is born in a certain way. Born that way and you can change it. But they have a drive, they have an urge to change things, to screw with their number of electrons so that they look like those purple guys. The celebrities, okay, the studs, the happy people. They basically are in the society of the elements. They don't do anything because they are pretty fulfilled with what they're born with. They have a full O word. What's that word? They have a full something. Starts with an O, ends with a T.
Octet.
Octet. Their octet is filled. Either they have 2 electrons like helium, or they have 2, 2, 2, and 2 in the 4 quadrants. Not necessarily in a flat surface, but in 3-dimensional shape. They have everything that every other element wants, and everybody here is trying to look like them or look like that guy. everybody here is trying to look like that neon or argon. That's the driving force to make molecules. If they were not motivated to look like so, I may mock the celebrities as much as I want. I may say it's a capitalist society, and I can have like a heated discussion. But sometimes this is why things happen. This is why we evolve. This is why we have a drive and an urge to make better. You know, like if we all were the same, like a herd of sheep, then we wouldn't change. We will just remain sheep for like millions of years. But humans are always trying to. I'm smelling something burning. That's making me nervous. I hope our department is not on fire, or I'm not getting fired. So that's why they just put like a little fire flame outside. Since I'm paranoid being a chemist, I think something is burning. 1 second. Always seems to be fine. The computer is not on fire. I think we're good. I'm just going to keep an eye, keep a nose on it. Okay, so what was I talking about? Yeah, the number of electrons on the outermost shell that can vary when two elements are coming together and forming a molecule. Two elements of the same kind, two elements of different kind, but multiple elements can come together and make a molecule. Okay, because every element, fluorine is trying to look like neon, oxygen is trying to look like neon, nitrogen is trying to look like neon by fulfilling their octet, by snatching, grabbing, sharing, equally sharing, not equally sharing, all the things that they can pull off from their bag of ammunitions and bag of techniques that they're born with. They will do that when two guys meet with each other. When boron and hydrogen get together, they do something to make them look like celebrities. Hydrogen is trying to look like helium, boron is trying to look like neon. This guy, lithium, is a little funny situation. Lithium and beryllium, sodium, calcium, those guys, it's difficult. Even though it's in the same row with this celebrity, in order for sodium to look like neon, it's going to be an uphill battle. It's going to be very difficult. Energetically, it's not going to be feasible. So for lithium, the low-hanging fruit or the easier way to look like the nearest celebrity is that guy, not this guy. So lithium will do something to look like helium, not neon. Beryllium will do the same thing to look like helium, not neon. Okay, but these guys will try to look like neon. If boron tries to look like helium, it has to get rid of a whole bunch of electrons, like all 3 electrons from its outermost shell. That's tremendously costly as far as energy is concerned. That's probably going to be like an atomic atom bomb, the energy equivalent of that. I don't know. Something ridiculously high, okay? When you try to move 2 electrons at the same time. If you want to, it's always easy to knock 1 electron from that guy and give it to that guy or this guy and make S minus and lithium plus or sodium plus and chlorine minus, sodium chloride, right? So that's why it's easier for this guy to lose an electron and it's easier for these guys to gain an electron. That's how you have more ionic bonds between the extreme left and not the extreme right, but the penultimate column. Because these guys don't need to do anything. They're just like born, like done. That's a bad description. Okay, I use metaphors from society and human beings, so don't call anyone like you're born done, because that person is very lazy. So these guys don't have to do anything. They have their octet full. These guys are trying to look like them. These guys are trying to look like them. These guys are trying to look like them. And they all have their own techniques. Okay. These guys, the halogens, can share, or they can snatch. Okay, whenever they can. When they snatch and run, they cannot run from the cation. They're stuck together. They like follow each other everywhere. That's an ionic bond. When they share, they're the nice people, because it's very difficult for carbon to like literally transfer 4 electrons. It's not possible. It's impossible. Okay, too much energy. Okay, so these guys try to make ions or covalent bonds. These guys can make ions. oxygen, sulfur, it's more difficult for nitrogen, phosphorus to make ions. That's one of the reasons. And carbon, silicon, those guys are not going to make ions unless you are really forcing it to. So carbanions is a big deal. Carbocations is a big deal. N minus is a big deal. N plus literally almost never happens. Okay, so I'm just giving you a glimpse of the periodic table. We are talking about what's an atom made out of. Atom element, what is that made out of? 3 different particles. What are the particles, and what do those particles, why are the particles significant? Because the number of them basically determines where they are on the periodic table. 1 proton, 1 electron, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, so on and so forth. And we're going to discuss like how they're organized in the shell or shells. This is not the only shell for all elements. Sometimes the shell that you can see when you look at an atom, the outermost shell, that's the only shell. But sometimes there is something else. There is another shell inside. There is another shell inside that second shell. So you can have multiple shells, and multiple shells have sub shells, and we'll talk about that in a second. So from here, I just wanted to give you a glimpse. I had something in my mind. So F minus has 10 electrons and 9 protons. Let's continue this quiz one with a couple more elements. This is what you might be expecting. Lithium ion, not a negative ion. In this case, it's a positive ion. Okay. As far as the electronics is concerned, just the number of electrons is concerned, who you think lithium plus is mimicking by losing an electron? Who does it want to look like? Which?
Helium.
Sorry?
Helium.
Helium.
Okay. If I ask you, how many electrons does lithium have in lithium plus? In lithium ion, how many electrons does lithium have?
2 electrons. Oh, negative or positive?
Doesn't matter. I'm just saying number. Number is not negative or positive. Number is always positive, right? Whatever we are talking about, that thing could be positive or negative. So number of electrons on a lithium plus lithium ion is 2. What's the number of protons for lithium plus?
3.
Somebody else agree or disagree?
Agreed.
Somebody else. I want everybody to participate. And those +1 bonus point, I might raise it to 2. I might just increase it depending upon how you respond in the class and how you keep your cameras on and be present. And that's bonus points. You don't have to do it. So if you feel very comfortable with the material, you don't even have to attend the lecture. You know, you can, I think with 100% grade, you have a lot to play with. You can, as long as you have 88 or more, then you have an A. So if, I'm not being sarcastic, or I'm not being rude or mean or anything. I'm just saying that if I feel very comfortable with the class and if I want to do something else, that's totally fine with me. I really mean it. No hard feelings. I'm totally fine. But if you're going to be shooting for those bonus points, you need to really earn those bonus points. And I'm already thinking about upping it by 1 more point. So the bonus point that's in the syllabus, at the end of the semester, I'm going to add to your total. That may not be 1, maybe 2, or maybe 3. Who knows? I don't know at this point. Okay. So number of protons in lithium plus, what's that number? Somebody else, not you two.
3.
Sounds good. Okay. Okay, so you get the point, right? So in order for it to be a cation, and in order for a species to be an anion, okay, between lithium plus and fluorine minus, which of them is called what? What kind of ion is this?
Anion.
How do you spell it? O-N-I-O-N? I'm just kidding.
A-N-I-O-N.
Anion. And what is this guy called?
Cation.
Cation. Okay. The take-home message is cations. You can keep your eyes closed and you can answer that way. If I'm asking you, you don't even have to open your eyes. You can be in your dream zone and you can still be able to answer. Cations have one less electron, have lost electron. They have lost electron. Anions have gained electron. Somehow, for whatever reason, they have plucked that electron from somebody. And a cation have lost an electron from whatever that urge or driving force was, had to do with, okay? And you know what usually those driving forces are. They are always, a cation would not have lost an electron unless that cation thinks that, oh, I look like one of those guys, okay? And an anion was not an anion where it was born. All these guys like to gain an electron and look like one of these, their neighbors, their celebrity neighbors, okay? So I'm going to take a 30-second pause and let you guys kind of absorb the material. I'm going to also take a picture kind of standing right in front of the camera because I think I was told by my SI leader for Chemie that that's the best way to take a picture. Okay? Sorry, excuse me. I'll just take a snapshot. There you go. Oops, I forgot to turn my phone off. Okay. I'll keep my mouth shut for like 2 seconds. Just let you guys absorb what we are talking about. Electron, proton, atomic number, blah 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 blah, how they're changing, and how do you get a formal charge? Let me add one more word. So these charges, negative or positive charges on an atom, that is what is called a formal charge. I'm going to take another picture and delete the other one. Okay. Okay. So the negative charge or the positive charge on an atom is called the formal charge. How do you calculate the formal charge? What's the easiest way to calculate the formal charge? Let's say you're dealing with lithium. What number of something minus number of something else will give you the formal charge? Number of formal charges. +1 or +2 or -1 or -2. It's not like general chemistry. General chemistry is like formula, total number of electrons plus blah, 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 divided by 2 or something like that. I don't like that. This is mostly concept. So there is a chance that you might feel more comfortable with the way we learn organic chemistry. At least I educate my students with organic chemistry. What's the easiest way you can get that number +1 by subtracting number of something from some number of something else? What are we talking about?
Number of protons minus number of neutrons. I mean electrons.
Anybody else wants to chime in?
I'm not sure, but I think it's the bond and the lone pairs.
You're making
Isn't
things,
it
you're
valence,
making things
valence
complicated.
electrons minus bonds?
Keep it simple. No bond. Right now there is no bond. Bond only happens in a molecule. At this point, there is no bond. All we are talking about is an element that has unfortunately lost an electron. Okay? So, how many protons does it have? Number of proton is what, and number of electron is what for lithium plus. Number of protons for lithium plus is, look at the periodic table and tell me what the number is. What's the number of protons for lithium plus? We haven't met.
3.
Sorry?
3.
What's the number of electrons for lithium plus?
2.
2.
Okay. How do you get +1 by using these two numbers? What do you subtract from something else? Or what do you multiply? Or what do you do? No lone pair, no bond, nothing. Just simple. Keep it simple. All you do is this. Okay? You take the number of protons minus number of electrons, and you divide the 3. I mean, that's turning out to be 3 minus 2 equal to 1 plus 1. That's the formal charge. Number of protons minus number of electrons is the positive or negative formal charge. For F minus, let's do the practice. We have very little space. We can probably pull it off here. Number of protons. What's the number of protons for F minus? And what's the number of electrons for F minus? Tell me.
9 and 10.
9 and 10. So the formal charge is equal to number of protons minus number of electrons, or 9 minus 10 equal to -1. Let's take a 1-minute break. I'll take one more snapshot. I'll replace the previous picture right now. I'll delete it. Move to trash. Okay, sorry. Excuse me. Okay, got it. Take a look at the board, decipher everything, and make sure that you guys are on top of all the concepts that we have so far covered. This is, again, sort of like review. I'll keep my mouth shut. Any questions? Just raise your voice. Unmute yourself. Don't talk to a dead microphone, and amuse yourself or your cat. Apparently, I've been told that my students' cats like to hear me when they're listening to the Zoom lecture. I have no idea. I don't know if I'm a cat whisperer. Matter, molecule, element. Element, smallest particle, atom. Made out of 3 things for now. We are going to ignore the neutron for the most part. Proton and electron. This is usually positively, not usually, that's bad. This is not usually, this is always positively charged. Electron is always negatively charged. Okay. Center is, the nucleus is positive, shell is negative. They balance each other, okay? And the electron is spinning around in a spherical way, okay? Elements are organized with their properties in mind and their electronic configuration. There are certain things about the periodic table that we need to learn. And usually we put things like a little motel. You get one person, that guy goes to the bottom floor, second person goes with that person, third person goes to the second floor, and each floor has wings. So they have shells, and the shells have subshells or sub levels within the shell energy-wise, and they're called orbitals. We'll get to that in a second. but the number of that atomic number or number of electrons slash protons dictate where each element is going to be situated. Hydrogen, helium, lithium, beryllium, 1, 2, 3, 4, 5, 6. That's the atomic number. Okay, and then we'll talk about other properties. Okay, and an atom can lose an electron or can gain an electron. When that happens, they become charged species. They're not a neutral element anymore. They're a cation, positively charged ion, or they're an anion, negatively charged ion. Okay. How do you calculate their number of formal charges? Formal charge is whatever charge they have. Number of protons, total number of protons minus total number of electrons. That's the thing. As we get to the Lewis dot structure, I think what some of you were thinking, bond, taking half the bond and taking the lone pair, that will make sense. As of now, keep things simple. We are not talking about Lewis dot structures. We are not talking about bonds. We are not dealing with lone pairs, so let's not talk about it. We are just discussing single ions, and we are trying to figure out why should Li plus be Li plus 1? Why should F minus be F minus 1? Okay, so that's how we deal with it. So that's what we have covered so far. Not a whole lot. Are we good? Any questions, queries? No? Okay, so if there is no questions or queries, what I'm going to do is I'm going to keep that periodic table up there. I'm going to delete, let's keep that unless we are desperate for space. Okay, let's erase everything here. Where are we with time? 1:30, 1:27. We don't need to have that label. We know what that is. Okay, so I hate when there are stains or marks on the board. Okay, so let's draw the smallest element, hydrogen, with 1 electron and 1 proton. Okay, hydrogen. Okay, I'm not going to draw very big. Let's draw it here. 1 proton, positive charge, and 1 electron, negative charge. Okay. The symbol for hydrogen gas or hydrogen atom is uppercase H, like the emblem of Hyundai or Honda. Okay, whatever H, like famous companies are out there. They have their shapes and stuff. Okay. Just a simple uppercase H, and we put the atomic number. I forgot on the as a superscript on the left or right. Where is it? Who remembers? Is it here or here? I'm just going to put it here. I don't remember.
Right side.
Right side. Okay. Thank you. That's the atomic number. That tells you that this guy has 1 electron. That's it. That's its atomic number. And this is how the exploded view of its atomic structure will look like. Okay. Now let's make some ions out of it. Okay. Nothing changes in the nucleus. Do not mess with the nucleus. Nothing changes. one proton, and that's that. Okay. Now, in this case, what I'm going to do is I'm going to knock off that electron and strip the normal nice hydrogen atom of its electron that it was born with. Only one electron, now it's got nothing. Okay. So this species, will name it something. So this actually doesn't exist. This shell is there, but it's empty. Okay, it's not, no electron is there. Over here, what I'm going to do is I'm going to put an extra electron to make it an ion. Okay, this is hydrogen element or atom. This is not a neutral hydrogen atom. This is not a neutral hydrogen atom. Some terrible things have been done to those poor hydrogen atoms. Okay, let's say this is 1, this is 2, and this is 3. Which one is the cation? 2, 3, or 1?
2.
And this is the anion, right? Right? So that's an anion. What is the formal charge here? +1, +2, -1, -5. What's the formal charge here for this species, for this cation?
+1.
What is the formal charge here? Somebody else. I want
-1.
-1. That's the formal charge. How do you get that number? Can someone articulate? Somebody who has not spoken today at all. Push yourself, get out of your comfort zone. How do you get -1 from numbers that you see here? Number of things, subatomic particles that you see in that species.
The protons minus the electrons.
Protons minus electrons. Number of protons is 1, number of electrons is 2. That's how you get that. Over here, it's +1 minus, like 1 minus nothing, it's +1. Okay, when it's a cation, when hydrogen atom is a cation, it is looking like something that usually we refer to whenever we deal with H plus. Whenever we deal with H plus, we don't call it H plus. We call it H plus, but oftentimes we use a different word to describe H plus. What is that?
Proton.
Sorry?
Proton.
We call it proton. Why do we call it proton? Can someone explain? Anybody? Articulate? Why is it called a proton?
Is it because it's nothing but a proton?
Couldn't be a better explanation. What is there? That's just a proton. And that doesn't happen with any other element in the periodic table. If you make a proton out of it, it has to be a hydrogen to start with. All other guys will have some electrons left over when you make a positively charged species. This guy would be proton plus. I mean, it's going to be something really weird, like, yeah, proton plus, because you will have to knock off 2 electrons to get to its 2 protons. But that's going to be very high energy because protons repel each other. And when you have 1 electron left, then it's going to be 1 proton, 1 electron neutralized and only 1 extra proton. So He++ will have a significantly high energy. It's probably possible to make that in some kind of a chemical situation. I'm not sure. I'll have to ask one of the inorganic chemists. I told you it's not just Missy, Dr. Garrett. There are 3 other people who are originally trained in inorganic chemistry in our department. You can ponder about that. Okay. This guy is called a proton or H plus. Why is H plus so important in the whole world? We talk about H plus all the time because species that can produce H plus, they're called something. Species that can accept H plus, they're called something else. What's the deal here? When did we start? 12:30. Well, how far do we go? 1:45. Yeah. Well, we are good. 10 more minutes. Okay. For a second, I thought, is time okay? Yeah, all good. Okay. So, what were you talking about? Yeah, proton. Okay, we talk about proton. What kind of species we talk about when they produce or they soak up proton? It's an A word and a B word. You have learned it in general chemistry.
Acids and bases.
Acids and bases. What's so great about acid with respect to proton? Acids can
Donate protons.
donate proton. What are bases according to that same definition?
Accept them.
They can accept protons, right? So they must have something that will make a proton happy. Okay. All right. So that's a proton situation. This guy, this dude is in trouble. It's a negatively charged species, and oftentimes we write it as this. I'm just going to use the negative charge. I'm not going to put the number of electrons. This is an H minus. These are also very strong in terms of reactivity. They're very reactive species. And does anybody happen to know when you have 2 electrons on a hydrogen atom, what are they called? They're not called hydrogen. They're not called proton. There is a special name on it. Anybody knows what they're called? It's an H, starts with an H.
Hydrogen bond? Or no?
No. It's a species. It's this species.
Hydroxyl.
Sorry, Vincent.
Hydroxyl.
How many more letters? The 4 letters that go after HYD, sometimes when you are sharing some kind of a transportation, we use that word. And that word, those 4 letters will be going after HYD. You do that sharing when you are sharing a vehicle, like your cousin says, hey, I'm going to Fresno State. You want to hop on the car? You don't have to drive today. I'll take you there and bring you back. What are you sharing with that person?
Hydride.
You got it. It's called a hydride. Now you cannot forget. Hydride. HYDRID, hydride. Hydride is H minus, proton is H plus, and H is H, neutral H. Got it? They're very critical. So I'm going to be putting more emphasis on certain aspects of organic chemistry because I really want you guys to understand, and I really want you guys to build your foundation very solid. Okay, we have 5 minutes left. So what's the best way to go about it? Okay. So that's one segment. That's one sort of discussion about the smallest element, smallest cation, and the smallest anion. This is very important because it's connected with acids and bases. I'm going to just write it down. Okay. Acids donate H plus, and bases accept H plus. Okay? Acids donate, bases accept. Good? Okay. So that's how hydrogen looks like, okay? And you know how to calculate formal charge. Okay. Next contender in the series. Let's draw helium. How many protons in the middle, in the nucleus? Can someone chip in? For helium, we are now talking about helium-2. How many protons in the nucleus, in the black nucleus?
2.
They're both protons. And looks good. The exploded view of helium atom. This is good, right? So now, as we go, and this happens to be an inert atom. This is an inert atom because of the number of electrons. It's very difficult to make He plus or He minus. Why would you make an He minus? Why would this guy want to have 3 electrons in its outermost shell? Why would it want to have 1 electron? Makes no sense. Okay. So this is pretty inert. Okay, that's helium. Let's go to lithium. What's the atomic number of lithium? It's not a trick question. 3. How many protons does it have?
3.
How many electrons does it have?
3.
3. Lithium plus, how many protons does it have? Quick.
2.
2.
How many protons does lithium plus have?
3.
3.
3.
No change in the nucleus. How many electrons does lithium plus have?
2.
2.
Making sense? This has to become like your thoughts in your dreams. You should plan on having a dream about what we are discussing. Okay, please, I insist. You can control your thoughts in your subconscious mind. If you're getting obsessed, then that means you're gonna have even a dream about it. How many protons in the nucleus?
3.
3. You guys are losing power. Proton, proton, proton. Okay. Electron, electron, electron. Is that it? Does it make sense, or is something wrong with what we have learned so far? Does it make sense, or you guys have forgotten? Anybody who remembers general chemistry or any other source of knowledge here, does it look right? Can you put 3 electrons in the shell?
Oh, there can only be 2 electrons in the first shell.
Okay, so there is something wrong here. So I'm going to just cross it off. Let's use green color. I know that you don't like the green, but once you see the picture, I think it will probably show up. You can see the cross. Okay. All right, so there's something wrong. Okay, all right, so let's correct it. Plus, plus, plus. How do I go about it? 1 electron, I'm done with 1, I have 2 more to go. What do I do? Help. I need somebody. Help. There's a Beatles song.
Another electron goes in that shell.
Another electron goes in that shell, but then what do I do?
At another show?
Another shell.
Oh. Now I This is correct. 2 shells. Okay. So this is important. This is very important because this is just 1 minute. Shell number 1. This is shell number 2. Okay. So there are a bunch of shells. Shell 1, 2, 3, 4. Okay. We are not going to. I'm not going to torture you guys with shell 3 and 4 too much. Pretty much we'll stay with the shell 2. Okay. There is a name for the inner shell and there is a name for the outer shell. This is, well, I already said it. So this is outer or outermost shell. There is a special name for it, and there is a special name for the hidden shells. Hidden shell or shells, the inner shell. Let's get that, and then I will call it a day. The inner shell is called something, and the outermost shell is called something else. What are those words? What is the inner shell called? The C word. Hurry up. 4-letter C, starts with C, ends with O-E. You've forgotten everything in the winter break?
Is it core?
Very good. Arjivan. The inner shell or shells, that is not the outermost shell. Whatever number of shell is inside this outer shell, outer surface, those guys, if there is one core shell. If there is 1 and 2 and this is 3, then 1 and 2 are core shells. Okay, that's core shell. C-O-R-E, core means inside, core of your heart, whatever. Okay, I'm not going to be poetic here. The outermost shell is also described with a more appropriate word. The description starts with a V.
The valence shell.
I think that's probably good enough for today. So I'm stopping the discussion right here. I'm going to take a picture and I'm going to post the pictures as well as the video. Start working on some problems. If it is appropriate, you can bring something. So if you want me to discuss any homework problems, it has to be relevant to what we have covered until then. Even if we covered that on Thursday, and if you will have a question from the homework set, we can probably take one homework set problem toward the very end of our discussion, like 140 or something, or 135 or something. For 10 minutes, we can discuss that. Okay. So if anybody has anything from the homework, like something really difficult, you cannot wrap your head around it, but it's relevant to what we have discussed until then, until Thursday 1:35, then it's fair game. So we can take that. Okay. I'm going to make everything available whenever I can. Okay. So I'm going to take a picture of the board again, and there will be 2 pictures uploaded and the video uploaded as soon as I can. Have a good day and see you guys on Thursday. Okay.
Thank
Bye.
you.
Bye.
Thank
Everybody.
you.
Yeah.
Thank you.
If you have any suggestions about my teaching, just shoot me an email or send me some notice on Canvas. I don't mind getting feedback. Okay. Bye, everybody. Take care. Have a good